complex analysis and third session of path integrals. So today we are going to do one of the most important path integral which will be repeatedly needed throughout the course. Okay, and we will also, a special case of that, we will try to interpret what it really means. Okay, there is a geometric meaning which will bring out. Then after that we will do some theoretical aspects of path integral, because those very few properties of path integral we may have to keep on using repeatedly. So, and most often the students and the teachers will be impatient, but if you want to master analysis, these are all very small things you should go through. Okay, right, let's get started. The integral which I want to talk about is the following. Suppose I have a real number a in C, sorry, not a complex number, and let me look at gamma to be gamma r. Okay, this is from 0 to pi to C, so that gamma of t is a plus r e power I t for t 0 less than or equal to t less than or equal to 2 pi. So this is a circle centered at A and with the radius r, right? And the function we want to look at is f of z equal to z minus a to the power n, where n is any integer, right? So we want to integrate integral of f over gamma. Okay, so this by definition we know is 0 to 2 pi f of gamma t gamma prime t dt. So okay, now what is gamma prime t? This a is a constant r and I comes out, so this is I r e power I t. This is the derivative. And what is f of gamma t? This is gamma t minus a to the power n, but gamma t is a plus r e power I t, therefore it is going to be r power n e power I n t. I hope I did it correctly. A minus gamma, okay, r power n, okay. I hope I'm right. Let us go to that. Okay, very good. So therefore this is 0 to 2 pi r power n e power I n t, and I times r e power I n t, sorry, e power I t dt, right? This is gamma prime t. Yeah, therefore this is equal to 0 to 2 pi. R is a common and I is also a scalar, they all come out, I r to the power n plus 1, and what I am left with e power I n plus 1 times t dt, right? Okay, now suppose n plus 1 is not equal to 0, then I have a primitive, right? d by dt of e power I n plus 1 t by I times n plus 1. Okay, this is e power I n t. Okay, therefore by fundamental theorem of calculus we know it is I r to the power n plus 1 into 0 to e power n plus 1 t, 0 to 2 pi of this value, right? Therefore this is going to be e power I n plus 1 times t by I n plus 1, and that is evaluated between 2 and pi, right? But remember, exponential function is periodic with 2 pi I. There is an I here, therefore t equal to 2 pi, it is going to be 2 pi I times n plus 1. Therefore that is going to be 1. This is also going to be 1. Therefore this is going to be 0. Okay, this integral is going to be 0, right? Therefore what have we found out? If n plus 1 is not equal to 0, then integral of z minus a to the power n over gamma, okay, this is 0. Okay, gamma is a r e power I t and 0 less than equal to t less than equal to pi, right? Now let's look at what is n plus 1. Suppose n plus 1 equal to 0, that means n equal to minus 1. Therefore, I am looking at interval over gamma 1 by z minus e. This is what I want to integrate. Usually when we will even write dz, okay, if you want you can write dz. This also you can write dz, okay, right. For example, interval of f over gamma, many people will write f of z dz over gamma, okay, right. But what is z minus a? We already know. Z minus a is r e power it. Therefore, this is going to be 0 to 2 pi, and f of gamma t is 1 by z minus a. Therefore, it's 1 by r into e power minus it. Therefore, 1 by r e power minus it, and gamma prime t we know is r I e power it and dt. Therefore, r cancels, e power it is 1, therefore it's I, therefore this is 2 pi I. Yeah? Therefore, we found this is a very important thing. Let us record it as a lemma. Okay, this will be very much used. Okay, let A belong to C, R positive, gamma t equal to a r e power it. That means gamma is a function from 0 to pi to c. Okay, 0 less than equal to t less than equal to 2 pi. I am writing. These are usually one writes the way, right? Then, and for every n integer, interval over gamma of z minus a to the power n dz equal to 0 if n is not equal to minus 1 and equal to 2 pi I if n equal to minus 1. That is, this n plus 1 is not equal to 0. This n plus 1 equal to 0. Okay, please pause, review, proceed. Right? Okay. So, this is the picture. I have A. This is my gamma R. Right? Now, we want to look at something special. So, let me write gamma R. Let me fix R. Okay? Right? And let K be an integer. Let me define gamma K of t equal to A plus R e power I kt, and t is again from gamma k is again from 0 to pi to, I hope I shared the screen, yeah, 0 to pi to c, right? So let's try to understand. Suppose k equal to 2, what does it mean? So I have 0 and pi and 2 pi. So as t comes from 0 to pi, okay, this is e power 2 pi I. You understand? Therefore, it already comes to this point here. Yeah, that is a plus r. Yeah, are you following? And again, so that means when it goes around, okay, and pi by 2 it is here, and at pi it is here, because this is twice. And again, once more it starts the journey, it goes around twice. When k equal to minus 1, let's try to understand what it means. Okay, that means I am looking at, if you want, take a equal to 0 so that it may be easier for you to understand. Let us do that so that I can also tell you what it is. So gamma, this is minus 1 I am taking at 0, this of course is 1, right? And what is gamma 1 at pi by 2? That is e power, let me also take r, okay, r e power minus I pi by 2. That means this e power I pi by 2, this is 1 r 1 by e power I pi by 2, but that is r 1 by I, that is r minus 1 into minus 1 by I, this is I squared, therefore I get cancelled, therefore it's r minus I. Do you understand that? Yeah? Right. So what it means is, well, it goes in this direction. Okay, at pi by 2 it is here, whereas in the, that means when k is negative, okay, it goes clockwise, and when k is positive, it went anti-clockwise. Okay, and this is so called a closed. Okay, in a circle is a closed path. When do I say a path is closed? If the endpoints are the same, that is initial point equal to the terminal point. If gamma is from AB to something. Okay, so this is a closed path. Though what happens is, when k is positive, okay, the circle goes around the circle. Actually, it starts from a plus 1 or a plus r, and it hits that point at k times. Okay, in the clockwise, anti-clockwise direction. If k is negative, it starts from a plus 1, but it travels around clockwise direction and hits a plus 1. How many times? Again k times. Okay, keep that in mind. Okay, so whether k is positive or negative, e power I k t, okay, right, visits, if you want, a r visits a plus r k times. As t moves, t varies on 0 to 2 pi. Okay, make sure you understand all these things. This is how you kind of get the geometry of what we are going to do. So what I want to do is, I want to integrate 1 by z minus a in gamma k. Okay, what is gamma k? Let us recall again. Gamma k is a plus r e power I k t. Okay, and this is what is the domain of interval? Domain of gamma k, it is 0 to 2 pi only, right? So let us do that. What is gamma k prime t? That is r I k e power I k t, right? And what is z minus a? Z minus a is r e power I k t. Therefore 1 by z minus a is 1 by r, right? Therefore integral gamma k dz by z minus a is, okay, this is going to be 1 by r e power I k t. This is 0 to 2 pi, and this is going to be gamma crime r I k e power I k t. Therefore r cancel, e power I k t cancel. This is k is common, 0 to 2 pi. Therefore it is k times 2 pi I. Yeah. So in particular, if I look at this number 1 by 2 pi dz by z minus a, this is an integer, okay, or gamma k, and that integer is nothing other than k. And what is the geometric idea about the k? This integral stands, okay, for the number of times the circle winds around or goes around a plus r, and it's a positive if it is anti-clockwise direction, and negative if it is clockwise direction. Okay, keep that in mind. If you don't understand also, it's okay, just keep that idea in mind and go through the computation. And you should stop the video, take a pen and paper, do it on your own. Okay, try. Okay, so the next thing we want to talk about is the properties of path integral. Okay, this property we will be using. So suppose gamma is a path, let as usual AB to U. Path meaning, remember, it's our piecewise smooth. Piecewise C1. Yeah, right. The first thing is, let us look at C of gamma, okay, in C. That is all continuous functions from the track of gamma to C, right? Then I have from this to C, I have a function f going to internal f of z dz over gamma, right? So this is, okay, this is a vector space, of course, complex vector space, and this is a complex linear map. Okay, this is very easy. Once you realize this is nothing other than f going to integral of a to b f of gamma t gamma prime t dt, right? And recall, we have seen that from C of ab to C the map f going to integral of a to b f of t dt. This is C linear. We had already seen that, right? So if I take f plus g, what does it mean? It is f plus g at gamma t and gamma prime t. That is going to be in a to b f of gamma t gamma prime t plus a to b g of gamma t gamma prime t, etc., etc. Okay, please convince yourself. It's very easy. One should not be wasting time on these things. Okay, okay, check the details. Okay, I had already given what is important. The second thing which is important, which I forgot when we did path integral the first two sessions, what should have done is what is called change of variables. Okay, this is what you have done in your 12th standard calculus when you do integration. When doing integration, there are only two parts. One is what is called substitution rule, other one is integration by part. These are the two most important tricks for integration. In case you are not understood, this is a golden opportunity to learn it. Okay, so what did you do? You do something like put, okay, something u equal to something f of x, then du equal to f prime of x dx, etc., etc. Do you remember such things? That's what we want to do. So let us do that. Okay, so what I want to do is, so let f be a continuous function from ab to C, continuous. Let H be a map from CD to R, so that H of the image is contained in the interval C AB. Okay, and what do I want? I want to be H to be C1, that is continuously differentiable. Right? Are you following? Then what do I want to do? Then I want to talk about, I have a function. What kind of function? I have a f composite h. From where to where? From CD to C. Right? Now h is continuous differential, therefore it is continuous. F is continuous, composite is continuous. Therefore I can talk about integral of f composite h of s ds from C to D. I will just denote the variables here as s. Okay, right? This is what I can talk about, but this is not what I want to talk about. Right? Let us do that. So now what we want to do is, let us put t equal to h of s, and this belongs to ab. Right? Therefore if I write f of t a to b, okay, dt, then dt is going to be h dash s ds. I am going to justify. Okay, I am just trying to recall what we want to do. Okay, this is how you did. And what did you do when s equal to c? Okay, then you want to say h. Okay, h of s, h of c is contained in a. Okay, is belong to ab. And similarly, when s equal to d, h of d is contained in ab. Assume this is a and b, but I don't require that. In that case, we said it is going to be c to d f of h of s h prime of s ds. This is what we want to justify. Okay, I am just motivating. This is motivation. Okay, this is what we want to prove. We want to prove this rigorously. By the time, when you did a real analysis, if you have gone through my course on Riemann integration, I would have done that. Okay, I do not know how many of you have gone through. It's the same proof. Okay, so what do we need? So let me look at a new function h of phi of s to be h of c to h of s, and f composite, sorry, h of s to be f of, how do I do that? 1 second. H of something into, oh, I just want to integrate, right? Okay. Oh, see, I'm sorry, f of t dt. I'm very sorry. This h, remember h of c, h of s, they are in the interval a b, right? Therefore f of t makes sense. This is our definition. Is that okay? Right. Now note, I want to look at what kind of a function. What can we say about this? Makes sense, right? Okay. About phi, right? Notice that s going to h of s, this is a c1 function, and then x going to h of c to x f of t dt, this is also c1 function. This is by fundamental theorem of calculus. Okay, whose derivative at x is fx, right? We had already seen it. This is h dash. Okay, therefore the composite phi, therefore phi is the composite, therefore phi is c1, right? And what is the derivative phi dash s? That is, okay, what do you have to do? The derivative of this, that is f of, right, f of h of s at the point x into the derivative of this, which is h dash prime s. Okay, and now let us use fundamental theorem of calculus. I hope I shared it. Yeah, fundamental theorem of calculus. Therefore C2, okay, phi of d minus phi of s, sorry, phi of c is C2d phi dash of s ds, right? Now what is phi dash of s? This we know. This is C2d f of h of s h dash of s ds, right? But what is phi of d? This is going to be h of c to h of d of f of t dt minus h of c to h of c, for, okay, f of t dt. But this is 0. Okay, therefore we have proved change of variable formula. Okay, pause, review, proceed. Now we want to give few applications. I want to give 3 applications. I do not know how much time I can spend because the video may become longer. Okay, the first application is a simple, what you call reverse path integral. That is path integral along the reverse path. So if gamma is a path from AB to U, and let A equal to gamma of A and capital B equal to gamma of B, then this is a path. Okay, this is maybe A, this may be my B, and gamma goes from here. That is it's like a train. It starts at time A from the station capital A, and time B it reaches capital B. Now what I want is, I want a simultaneous another train reversing the path. That is, at time A it starts from the city B, and at time B it reaches city A, right? So how do I do that? Okay, that is, let us call it gamma tilde. Therefore at A I want it to be B, and at B I want it to be, this is gamma B, and at B I want it to be A, right? So at B I want it to be A, therefore what should I have? T minus B, yeah, so A plus B minus e. So at to b, therefore I should be either t minus b or b minus t. Then I have to add a. Do you understand that? That's a translation. But I will come to a proof. These are the things you have to learn, because I can just write down the formula. You can check it, verify it, but you should learn how to do that. Okay, this must be the thing. So I may have to define gamma either this way or this way, which is correct, because when t equal to b, it's at a, but when t equal to a, yeah, this is yeah, b minus e, right. Okay, this is okay at t equal to b, this is a, and t equal to a, sorry, t equal to a, I want it to be b. So what should be the correct one? Are you following? At t equal to b, this is a, okay, but at t equal to a, okay, this is 2a minus b, this is not correct. Whereas when I put this, when t equal to a, that also cancels. Therefore this is the correct formula. Do you understand this? Yeah, I just want you to think. Okay, so we define gamma tilde at t equal to gamma of a plus b minus t. So the teacher writes this, you have to memorize and verify. When t equal to a, this is b, gamma b, and t equal to b, it is gamma a. So it seems to be all right. And the map is t going to a plus b minus t followed by gamma. This is C1. This is also piecewise C1 or C1. Therefore the composite is a path. Okay, this is a path. And next I have to make sure a plus b minus t lies in the interval ab. Then only gamma will make sense, right? That's again very easy for you to check. Okay, are you following what I am saying? Yeah, because how do I do that? Take t, where does it? This is a less than or equal to b, less than or equal to b, right? Therefore minus t, what I take, minus a greater than or equal to minus t greater than or equal to minus b, right? Therefore add a plus b to both sides. Then I have a plus b minus a greater than or equal to minus a plus b, that's greater than or equal to minus b a plus b. Therefore b greater than or equal to a plus b minus t greater than or equal to a. Okay, these are the things one usually never checks. Okay, just assume this. Now there is another way of getting the formula. I just want to teach you how to think. Okay, not just memorize the formula and verify it works. Okay, now what do I want is I want from AB, I want to again AB, but then what I want is A should go to B and I want B to go to A. And remember, it's an interval going to interval, therefore it's a line segment, right? Therefore what I am looking for is this is the, let us say this is A, this is B. Okay, therefore this is AB and this is, okay, the A B, and this is B A, therefore it will be, this is A, therefore it should be here. So this is something like A, this is something like a B, right? This is my B, this is B A. So I want the line segment, right? You write down the formula for this using your coordinate geometry, connecting points x1, x2, y1, y2. You have the formula, write it, then you will see the formula is y equal to a plus b minus x. That's what we got. Okay, so these are all unnecessary preliminaries, not related to complex analysis, but learning mathematics properly. Very good. So what do I want? Now I want integral of f over gamma tilde. Now notice that the track of gamma and gamma tilde are the same. Okay, because gamma tilde of t is gamma of a plus b minus t. So that's again in the image of gamma, right? And conversely, therefore this is correct. Therefore f is also, I can think of as a continuous function from this. Therefore this makes sense. Right? Very good. So what do I expect? Remember what is the physical interpretation we had about integral of f over gamma? This is gamma. I think of f as a complex force. Okay, so integral of f over gamma, The physical meaning is I move a particle from gamma A to gamma B along the path gamma. It is a work done by the complex force, right? Therefore, when I go in the reverse direction, what should I expect? I should expect the work done must be negative of the earlier work. This is what I should expect. Okay, is it true? Let us check. Integral f over gamma tilde is integral a to b f of gamma tilde of t and gamma tilde of prime of t dt. Right? Now gamma tilde of t is gamma of a plus b minus t, and this is a combination of two maps as I said. Therefore gamma tilde t is t going to a plus b minus t, its derivative, and this. Therefore gamma prime a plus b minus t into derivative of minus t, which is 1. T going to a plus b minus t. Remember, it's a composite of two functions, right? T going to a plus b minus t followed by gamma. Therefore apply the chain rule, gamma prime at this point and the derivative of this. Okay, by now I hope all of you are comfortable. Therefore this is the one, right? Therefore, and this is what a to b f of gamma of a plus b minus t into gamma prime of a plus b minus t times minus 1. So let me put a minus 1 dt. Yeah, now what do I want? Okay, let me do sketch of t equal to a plus b minus t. If you want, call it as u. Then what is du? du is h prime t dt. What is that? That is minus 1 times dt. Are you following? So I want to make a change of variable. Okay, therefore this is equal to, there is already a minus sign, a to b f of u into, this is gamma prime u into this dt is going to be minus du, minus of du, by change of variable or substitution. If you have done your two variable calculus or vector analysis where you did path integral etc., all these things you would already gone through, except you would have a dot product there, but the analysis arguments are exactly the same, right? Okay, but then I have to, this is not integral, so I'm sorry, here also I have to be careful. And when t equal to a, what is u? U is b. When t equal to b, what is u? It is a. Therefore this integral is not what I wrote, but it is b to a. Yeah, therefore there is already minus 1 squared into another minus 1 into a to b, because integral b to a is integral a to b f of u gamma prime u du, but this is minus integral of f over gamma. So we proved. Okay, pause, review, proceed. Yeah, is it okay? Right. What is the second application? Second application is a change of variable. Okay, again a change of variable for path integral. That instead path integral remains the same under a change of variable of the path. Okay, don't worry about, I am going to explain. See, gamma is a path, right? See, for example, let's look at very simple example, 0 to 1, right? Gamma t equal to t and t running from 0 to 1, right? Now I can also define sigma t equal to t cubed t running from 0 to 1. Notice that this is also C1, right? And what is sigma 0? 0, sigma 1, 1, and sigma prime 0 is 3t squared, which is, except at 0, it's always greater than or equal to 0. It's actually greater than 0 if t is not equal to 0. You follow that? So, what is the meaning? So, gamma is also a path. At time 0, it starts at 0. At time t equal to 1, it ends at 1. Sigma also does the same thing. But then the important thing is the speed, the speed, gamma prime is the velocity vector. In this case, it's a real number. Therefore, so you call it a speed. Without if you put a modulus, it's a speed. Okay, norm of the vector is the length of the vector. Therefore, norm of the velocity vector is the speed. Right? These things, physics, you know that. Therefore, gamma prime t is 1. That means it's a uniform speed throughout the thing. Whereas when I look at sigma t, it is 3t squared. Therefore, the speed is variable. It depends upon what t is. Okay, at time t, the speed is 3t squared. It keeps varying. But on the other hand, at the same time interval 0 to 1, it starts at 0 and ends at 1. Okay, so we are simply reparametrizing. That is the same track, same time interval, but the train, instead of maintaining a constant speed, it may allow to vary the speed. This is the basic idea, right? So this is what we want to capture. So how do I do that? These are all actually part of several variable calculus and differential geometry, but I'm just repeating these things because it's very rarely done carefully. That's why. Okay, so let gamma be a path from AB to U, which is in C. It could even be Rn. Okay, and suppose H is a function from CD to AB, which is bijective, C1, and H dash is positive. So that means H of C must be A and H of D must be B. You follow all these things? For example, this one almost does it except at t equal to 0. The earlier one, sigma t, the parameterization was t going to t cubed. This is a parameterization. Therefore, okay. So now let's consider the path gamma, which is gamma composite h. That is sigma t is gamma of h of t. Now this is a path. Why? This is C1 by construction. This is piecewise C1. Therefore, on the intervals ti to ti minus 1 to ti, gamma composite h is C1. Do you follow that? Therefore, this is a path. Therefore, if f is an integral from f is a continuous function from the track of gamma to C, okay. Now notice that the track of this is same as the track of this, right? Therefore, f is also a continuous function from this to C. Therefore, I can talk about integral of f over sigma and ask what it is. Do you understand the question? Pause, review, proceed. Okay, H is called a reparametrization, reparametrizing map, and sigma is called a reparametrization of gamma, and sigma is a reparametrized path. These are all jargon. Okay, you should. Okay, where teachers may have different ways of saying, it's the same, all remain the same. That's why if you understand the concept, slight difference of notation will not confuse you. So let us go back to the definition. What is sigma t? Sigma t is gamma of h of t. Therefore, wherever sigma gamma prime makes sense, only at those points for t in ti minus 1 to ti, all our computations. This is by chain rule gamma prime of h of t into h prime of t. Is it okay? Right. Therefore, integral of path integral of f over sigma is integral c to d f of sigma of t, sigma prime of t dt. right? But that is nothing other than C to D f of gamma of h of t into gamma prime h of t into h prime t and dt. Is that okay? Now let's put u equal to h of t. Then this fellow, okay, when you, therefore what happens? Du is h prime t dt, and when t equal to c, h of c is a. When t equal to d, h of d is b. Therefore the interval is a to b f of gamma of u, and this is gamma prime at u, and this is du. But this is nothing other than path integral of f over gamma, right? So go through these two applications. As you can see, in everywhere what we need is chain rule when you want to compute the derivative of the path, and the second thing we needed was change a variable formula or substitution rule, right? So we will have a third application and stop with that because the time will be up by then. So what is the third application? Because in fact I would like to give again uses of these things, but we can wait. Yeah, let's go to the reverse path. Okay, do you remember we did when gamma r is a plus r e power I t, okay, 0 less than or equal to t less than or equal to 2 pi, right? And then we define, okay, this is gamma, let us say gamma r, this is simply say gamma 1, okay, r is fixed, gamma minus 1 is a plus r e power minus I t with the same t. Then we said integral of f over gamma 1 is 2 pi I, and whereas integral of f over gamma minus 1 is minus 2 pi. We already saw that in the earlier thing in today's 3, the first part of the equation. Now let us look at what is gamma minus 1. Gamma minus 1 t a plus r e power minus I t. So what does that mean? At t equal to 0 I start here, t equal to minus pi I come here, right, pi by 2, then I go here, right? You follow that? Yeah. Therefore I claim gamma minus 1 is same as gamma tilde. How do I check it? What is gamma tilde of t? Gamma tilde of t by definition is reverse path, right? That is gamma, remember, gamma tilde of t is gamma of a plus b minus t. It's a short term memory, I remember that. Otherwise, if I start from the lecture, I will actually prove that, okay? I don't remember it. It's just because we did it few minutes ago, I remember this. Therefore here what is a? A is 0, pi is 2, b is 2 pi, therefore it is 2 minus t. Therefore this is a plus r e power 2 pi I times 2 pi minus t. This is a plus r e power 2 pi I into e power minus t, but e power 2 pi is 1. This is nothing other than gamma minus 1. Do you see that? Therefore it's not surprising integral f over gamma minus 1 is integral of f over gamma tilde, because gamma minus 1 is the reverse path. Okay. Again notice that none of these things are required, but this is the way you become more comfortable with understanding of path integral, reverse path, all these things, okay, and our earlier computation. This gives us insight. That's when I become very confident of what I am doing, rather than simply going for theorem proof, lemma, and this appear for exams. Okay, let's go back. The third application, So I am going to application third now. Now remember, we already did what are meant by the juxtaposition of two paths. Okay, gamma 1 was from a1 b1 to u, and gamma 2 was from a2 b2 to u perhaps. Then we define, okay, such that gamma 1 of b1 is gamma 2 of a2. The end point of the first path is the starting point of second path. Okay, I don't want to keep doing all these things, so we define gamma t. What is gamma t? That was in the right, gamma was from a1 to, what is the thing, a1 to b1 plus b2 minus a2. Alright, a1 b1, and then I added b2 minus a2, that interval of that length a2 b2 I added to b1. All these things I justified. I don't want to keep saying. This was gamma 1 of t and this was gamma 2 of, then I have to do something. How did I do that? So if I start with, this is b1 plus b2 minus a2, therefore if I start with the t, okay, then I have to say what it is, t minus b1, right? But then when t equal to b1, I should have started with a2 because gamma 2 should be a2, therefore it should be a2. I hope I am right. Let us make sure. When t equal to b1, it's gamma 2 a2, that makes sense. When t equal to b1 plus b2 minus a2, so minus b1 minus a2 get cancelled, I get a b2. So this is the correct one. Okay, please go through it. Every time, just don't recall from memory, just quickly verify. You may think you are wasting time, but then remember, okay, the more you do, okay, it becomes permanent in your memory. How do you think that your multiplication table should just like that go and say now? That's because repeated use. So that's what we are doing here. Okay, so now what I expect, so this is something like, now let's again look at the physical meaning. This is my gamma 1, this is my gamma 2. Gamma 2 is shifted here, so I moved a particle from here to here and then from here to here, but then I move the same particle along this. Therefore what should I expect? What should be the work done? This is again a guess. What should I expect? It should be integral of f over gamma 1 plus integral of f over gamma 2. This is a guess. Do you accept it? Pause. Review, proceed. Now let's go through the proof. It's very easy. Integral of f over gamma is integral of a1 to a1 plus what is it, b1 plus b2 minus a2. Yeah, this is one. This is f of gamma t, gamma prime t dt. Is that okay? But this I can break it into two parts. This is integral. Remember, integral of a to b is integral of a to c plus integral of c to b, right? So I can use that. Therefore it's integral of a1 to b1 and f of gamma t, gamma prime t dt plus integral of b1 to b1 plus b2 minus a2 f of gamma t, gamma prime t dt. Okay, but on the interval a1 to b1, gamma is name as gamma 1. Therefore this is gamma 1 of t and gamma 1 prime of t dt. Therefore this fellow is nothing other than integral of f over gamma 1. Make sure you understand this. Okay, pause, review, proceed. Now let us look at this. Now what do you think I should do? This I know this is going to be okay. Now what is this? Let us write it, b1 plus b2 minus a2 f of gamma 2, okay, well, that is t minus b1 plus a2, if I remember right, yeah, into gamma 2 prime of t. What is gamma 2? Okay, we saw that this is therefore gamma 2 prime of t is gamma prime of t. Sorry, let me go back. So what is gamma prime of t? For t in the interval b1 plus b2 minus a2. This is gamma. So gamma t is gamma 2 of t minus b1 plus a2, and this is t going to t minus b1 plus a2, that going to gamma. Therefore, by chain rule, gamma prime t for such t is going to be gamma 2 prime at t minus b1 plus a2 at whatever point. Is that clear? Right? Therefore, this integral becomes, second integral becomes b1 to b1 plus b2 minus a2 f of gamma 2 of t minus b1 plus a2 into gamma 2 prime of t minus b plus a2 into dt. I have not done anything except I computed. Right? As usual, again let's do. Let's put u equal to t minus b plus a2. Right? And therefore, when u equal to b1, this is t minus b1. When u equal to b1, okay, sorry, when t equal to b1, u equal to a2. When t equal to b2, b1 plus b2 minus a2, u equal to b2. This is how we constructed there, right? Therefore, this map becomes a2 to b2 f of gamma u and gamma prime u, and what is dt? Dt is du. Therefore, this is integral of f over gamma 2. Therefore, what we have shown? Integral of f over gamma is integral of, where gamma equal to gamma 1, gamma 2 is integral of f gamma 1 plus integral of f over gamma 2. Pause, review, proceed.